All right, ladies and gentlemen, here's your check for 8.9a. Please make sure that you have checked in with Miss Walker before you start this check. What scientist first was formally proposed the Earth's land masses were once joined together as one giant supercontinent that had since drifted apart? And we all know that's Alfred Wagner. The name that was given to the supercontinent was Pangea. Was the hypothesis accepted by the scientific community when it was first proposed? No. Why or why not? He could not explain how the continents moved. And remember, you have to be able to prove as scientists how things work. People won't just believe you at first. List 3 pieces of evidence used to support the continental drift theory. The first piece of evidence is fossil evidence, plants and animals. You could choose glacial cues. Continents fit together like a puzzle or a jigsaw puzzle. Climate clues, or matching rock structures. You can choose any of the 3 of these pieces of clues. Harry Hess discovery of seafloor spreading provided the mechanism to explain how continental drift could work. These 2 hypotheses were merged into what is known as the Plate Tectonic Theory. It proposes that the lithosphere is broken into plates that float on top of the asthenosphere, and the asthenosphere is one of the layers of the Earth. 8.9b, crustal features. Please make sure that you have already completed this section before you start to check. Label the layers of the Earth in this model. First layer is the crust. The second layer, as we go down, is the mantle. Third layer is the outer core, and the last layer is the inner core, which is very, very hot. Let's look at these types of boundaries that cause our plates to move. So the first type of boundary is called a convergent boundary, and this, of course, we know creates mountains. The second type of boundary is a transform boundary, which creates earthquakes. And the last type of boundary we have is a divergent boundary, which causes a mid-ocean ridge, which is under an underwater volcano. Ooh, my speech today. All right, use these images below to correctly match each crustal feature to the plate boundary interaction that would create it. So let's look at plate boundary A, plate boundary B, plate boundary C, plate boundary D, and plate boundary E. Go ahead and go over your hand motions so that you can remember what these plates form. So folded mountains would be formed at what plate boundary? C. C goes up into create a folded mountain. Faults or earthquakes will be created at plate boundary B. An island arc or a trench or a volcanic island, which will be created in the middle of the ocean, can be created by plate boundary A. Volcanic mountains and trenches can be created by plate boundary E. And rift valleys or mid-ocean ridges would be formed at plate boundary D. Now, because plate boundary A and plate boundary E look very, very familiar, I will take E for island arcs as well, and I will also take A for volcanic mountains because they look very similar, and there's no way to tell which is which. All right, go and check with Miss Walker so you can get your grade.